Hi everyone. We are here in the importance of zero energy buildings in carbon neutral future. We have very prominent speakers. They have important studies and research. It is the buildings have an important share in the consumption of energy and in struggle against the climate crisis. The zero buildings transition will have an important role, and the European Union made it mandatory to turn into zero energy buildings, and we can say that the 30 or 40% of the buildings share in the energy consumption, and we have to act in this regard, and we need to have the improvable energy, select the right materials, and focus on technology. So I'd like to give the floor to Dr. Nuri, Kayaçetin, the Leuven Faculty of Technology Engineering, postdoc researcher. He's going to talk about circulatory tools and LCA in nZEB design. The floor is yours. Thank you very much, Didem. I'd like to thank the organizers for giving me the chance to make such a presentation. So I'll share my presentation if that's okay with you.
Şu an görünüyor mu acaba sunumu?
Can you see it? Can you see my presentation right now? Yes, we can.
Didem Hanım da bahsettiği gibi ben bugün
as Didem Hanım pointed out,
tasarım konusunda destek
so in the design there are some activities and also life cycle analysis.
Daha önceki sunumlarda da görmüş olduğunuz
as you can see in the previous slides, the net zero energy buildings are there with the performance, and we can I'd like to highlight the use cases, use structure, and in Europe it is about having this within the scope. However, in recent years in the UK, in addition to carbon emission, and of course there is a system for that, and for the European Union and one of the I'd like to talk about the basic structures, and it's about the directive, and for nZEB it is a certain structure, and there are some certain ones, and there are some this goes through the carbon emission. Of course, there should be the cost-effective evaluation should be there, but in this regard, I'd like to talk about the role of the energy, the embedded energy. In nZEB, it's about more of an operational performance, and we call it as a carbon. So in the buildings, and at the end of this, when we look at the right, and we see the embedded energy. So when we have this, and we have to look at this, so the energy is not involved there. So this is roughly that, the nZEB definitions that could be the developments, as you can see in the graph. It is about the ones with the yellow ones. And here
binanın üretiminde kullanılan
we see
enerjiyi arttırıyoruz. Bunu nasıl yapıyoruz? Binaya daha
how
çok
do we do
malzeme
that.
katarak yalıtım
We
yapıyoruz.
have more
Bu
of
noktada
insulation.
kullanım enerjisiyle gömülü enerjinin
And
alış ve
with that,
alış dışındaki dengeyi
there is
iyi
the
değerlendirmemiz
ones.
gerekiyor. Buradaki asıl binalardaki gömülü
And when we
enerjinin
look
önemi
at
bizim
this,
için ne olabilir? Bu gömülü enerjinin çok fazla
for the embedded energy, it shouldn't be increased too much. We have to use the local materials in this regard because in the transportation of materials, you also spend energy.
tercih edebiliriz. Biyolojik tabanlı ya da hafif yapılar.
So there are biological ones.
Bunların önemi ise artık bir binanın 50 sene içinde
And
tükettiği enerji
we can see the energy.
safhadaki enerjiyle eşit. Yani şunu demek istiyorum. 3 senede inşaat
So
3 senede tamamlıyorsun.
as 3 years in the construction, so the energy in there is equal to the energy for the 50 years. So we understand that there is an energy there and how to look at this. And here there is 70 or 90% of there is operational emissions are more weighted. And when you look at the better buildings, so of course there should be energy intensive buildings, and the emission there is about the energy, and it's about this. This is a life cycle, and taken from this, and we hear the other second amendment, and this is 50 years, and there are some sharp increases there, and it is the embedded energy. This is the standard building, and while making a more efficient building, in the 5 years there's more of an energy, but as the performance is better, there is less emission in total. But we shouldn't do something. So we have to do it with respect, and we can have it this way. And we put so much materials that it is more than our savings. And we don't want to invest more in this system. And you have to have it. And there needs to be an efficient material. We can go back to our sense. Maybe the energy is already in the buildings, and we use these buildings as resources. And regarding that, and there are some new developments that there is for the demolition and disintegration of the building. These are the ones, and of course there is mining there about the ones, and there are these concepts. We can see that it is about receiving the demolitions of the building. So if you have a potential, if you cannot look at the potential, you need to have some tools to look at this. And this can be done with certain principles. We know the recycling, the reuse, and also recovery. I will not go into details of them. So what we do in so there are 9 different ones, and we looked at it in different terms with the the materials imported and exported, what we see is about the filling and the ones that couldn't be used. And when we look at this, it is about the reuse potentials of this. When we look at the studies, what we saw was that the reuse is about, it is not an obligatory application to do that. And when we look at this, it is the area, and it is the one there. It's for about the effects on the environment and reuse and recovery strategies, so we can save a lot. And we have to take into account that this is in the life cycle of the building, but for the future, it is not going to a tolerance that we will steal from the future because of the, we have this information right now. When we look at the nZEB and the zero energy building discussions will be changed, and the embedded energy, it should be in an operational energy. So the consumption of operational energy can be decreased down. It's the building. We can increase we can make additions, increase the installation. The embedded energy is within that, and so the circulatory tools are important for the buildings. It is not operational, and we can have energy efficiency gains. So we need to focus on the long-term scenarios. We have we know that, and we can look at a certain ratio here, but it doesn't show the real potential. We can have the system 4 sites, and with the 4 sites, we can have a better acceptance, and we can see the effect of the design. This is all from my side. If you have any questions and comments, I'd like to answer them with pleasure. Thank you very much for the information you provided. So for the questions, all the people will ask, will finish their presentations, then we will have this, and we need to change it there, and the long-term system is very important. And of course, the buildings is very important. And thank you very much for your presentation. From Ayçam, Besen, the Board of Directors from Listen, we can listen to your presentation. The floor is yours, Ayçam. You're muted. We still cannot hear you. You are muted. I can't hear you. Maybe we can proceed with the next speaker, and you can solve the problem of sound with our friends, if that works for you. Didem, I did Ayçam from Gazi University, an academician. As Kayaçetin pointed out, there are important technological developments that are important for the zero carbon. And you're going to talk about the new the innovative technologies in the zero buildings. You have the floor. Thank you. Can you see my slides? Can you see my screen? Can you see it right now? No. Thank you very much. I'd like to thank you, and I'd like to thank Zero Build Turkey organization for giving us this chance to talk about the importance of this, and I'm very happy for them. When we say zero build, zero energy with the architecture, then we can see how we can use the technology in the design of the building and in the construction and in the implementation of the building. How to realize this technology is very important. So I'll talk about the zero building, zero energy building. I'll talk about the components. I'll talk about how energy is used. This is an energy efficiency is there. And we can say this, and the lighting cooling here, and there is a need of a lot of energy. And we can see that efficiency is high. And we are talking about such a building with a high energy efficiency. Of course, in the planning, design, and maintenance, and operation, in all of the stages of this building, there is a decrease of greenhouse gases and decreasing the environmental effect to minimize this effect. And so, there are different terminologies and it changes. So we are the zero, we can call it as a, zero, near zero building and simple zero buildings. And there are some differences there. And it's about increasing the system, and the objective here is there are the simple definitions of this. We have to be careful about the two things. There are passive solutions, and of course, using the renewable energy system and producing energy with that. And of course, there are two approaches here. One is about the decreasing energy ones. And we see the control systems, and we can have this. So the second one is that it's about producing the clean energy in the field and to adopt it there. And there could be a PV system, and there could be a system, and there could be a solar panel or wind turbines. Can be the reason, and we have to have it in the system. It's important that we have this. So how to make a building, for example, here in these buildings. And in all the cost efficient materials that we will see, and of course there will be a renewable energy system. And while doing that, of course, we can make use of the network and grid, and we have to come up with a solution to that. And of course, we will have this technology with the passive systems and to integrate it with these systems. So for that, the strategies should be there. And of course, it's about using the new ones and also having it with the buildings. And it is about the ones, as I can say. And there is no thing about that. And of course, there needs to be a new system, and this system should be within that whole overall system. It's not like using I'm a system and now I have a zero energy building. That is not the case. And it's for the country dynamics, for the building dynamics, and it covers many criteria. And of course, it should be taken into account. Of course, it's about the optimization as well. It is not an easy decision to take, as I can tell you. So what do we do in this regard with these technologies? What strategies do we use? Of course, it's about the performance and it's about the optimization. This is how we need to have. And we have to look at the opaque ones. And we have to look at the mechanisms. So we have to take them into account. So we need to have the right technologies, and we need to have passive and active resource systems. And of course, when the electricity energy is used, of course, they're using the solar energy. So it's about this, and of course, we need to take which one is efficient for us. And of course, we can use the hot water collectors, and also we can have technologies. And there are SolarWall applications or phase-changing materials, and also the integrated walls that we see with the supported with the passive or active systems, and we can integrate them in the building. And also, we can use these systems, and we can have that system. And for hybrid, and we can look at that system with the renewable energy. We can take them. Of course, what we have to do is about the net zero buildings. What we have to do is that we have a passive system, and in the envelope systems, the optimization should be there, and we have to optimize the system. And of course, we need to decrease the heat island effect. And so when we use the renewable energy, it's about using natural resources. And using the passive techniques, and integrated this. And in these systems, and of course using that system, and that will increase the performance, if I might say so. There are two concepts that I'd like to say. It's about the building envelope, construction envelope to be designed in the right manner. And in terms of insulation, and the opaque and transparent elements should be designed in the right manner. And for all the equipment, these should be evaluated right, and the techniques should be taken into account, if I might say so. I'd like to give you some examples. When you look at the end of 2000s, we can say that there are different building types, and the new buildings and ones. And of course, there's an increase in that system, and this is for the singular buildings, and for the other building types, it is realized, and we can say that especially in commercial buildings, for example, the fair buildings or the science-based buildings, that there's more visual, the energy or the technology is more established, and also the use of them is encouraged more, and we see that it is applied more. So when you look at Turkey and the world, we can say that the buildings are high in number in the world and in our country. For example, there is a building in China. It's a scientific center, and you know that these are the buildings. It's a partial building, and the cooling and heating systems are designed together. And for the walls and the suns, there are solar panels, and with photovoltaics, renewable energy is designed by the precipitation or rainwater is used, is evaluated for the water consumption, as we can observe. And it's a building, it's an assembly and the assembly system. It's a more empirical building, and also this is designed, constructed, and informed, and it gives the added value to the others. And this is a country example. And of course, with the high, there's a high envelope with a high energy, and there is the heat pump. There's a hybrid heating system, and for the collection and purification of the water, we can say that they're making use of other technologies. And of course, we see the renewable energy, and of course, we have to use it there. And this is an extra gain, if I might say so. This is another example, a health building. There's some community college, and here we see that when you look at the price and performance, there's a high performance envelope, and it's how it is. Then there is a minimum and maximum performance. And also we see that the ones in energy performance, and the design is designed in the right manner and proper way. And here in 2020, it is zero. It's a building with an award of zero net energy. And of course, there are passive and active many systems, especially in terms of heating and cooling. It has to be designed in the right way and evaluated, with the automation. And this is an example that we can give for that one, for that application. Another interesting application is a community college in Los Angeles. And I will not talk about the district decisions or campus decisions, but for there are an innovative technology for the envelope, and the envelope is designed in the right manner. And in addition, in line with the climate, there are integration of photovoltaics or lighting directing systems, or for the systems for the integration of the systems for hot water. And layer by layer, it's a gradual design is made. And now we can say that this is important for this building to there. And of course, it's an important parameter. And of course, it is important for the innovative materials. And this is a simple building. And of course, we are talking about we think that if there's a phase-changing material, so with the photovoltaics integrated in the walls or with the special ventilation, we wish that we could have a building which is efficient, and we think that will be very nice, and we have to disseminate them. Why not? This is what I'd like to say. Such a envelope design can be very good, which increases the sunlight, and of course other extra elements in these technologies. And there's a passive and active system, so it can be used together, and special sections with the details can be realized as an application, which is made in the recent years, as an example.
I want to show you more cases. When we look at the scale, although it was built earlier, it is still valid. It is, and we still have some feedback. Hope that there will be more projects that are better than this, and we will have this type of projects. It is a building that has offices and also individual houses. And choosing the right materials and also choosing the right system and also operating the system, it's a successful case. Of course, it is the heating and also the cooling systems and using the solar energy panels, and also heat recovery system that is sensitive to winds and also cogeneration systems, shadowing elements with pay attention to angles, etc., and the locations. Of course, I'm not talking about high quality materials, so it is quite successful in terms of selection of materials and the water treatment and also recycle of the waste. These are other successful elements of the project. So I think it is a good practice and it's a good case, a successful one. Another example is from 2013. It's an office building, and in this one, the envelope and also the roof were designed to generate power, and also it enables to get energy from the roof and also from the core. While it was being designed, the building operation modeling systems were benefited from this building operation system modeling systems, and they were designed step by step for this building. And in this one, we have these targets that the team estimated, that the team forecasted, and the design was made on the basis of these estimations and the calculations, and there were certain simulations in order to achieve it. There were simulations and also profiling several times, and the development of the building to forecast next 25-50 years, and in the long run integration was taken into consideration so that developments can be calculated in the right and in an accurate way. So it is another example, important building, the ballot center. As I said, we have passive and active systems that are integrated, and we have so many applications in the envelope and in the roof, and we have the system to generate power. And as I said, it enables to have a flexible design. For example, the roof can be used for 5 years. That's the first estimation. But when it is integrated, it can be reinforced. And then, since it enables to have a more flexible design, it has an added value. It's an old library area. nZEB library was built, and in this one, energy for heating was generated from the roof, and similar other techniques are used in an integrated with the building itself. Of course, you can look at more details after my presentation, and in order to improve the performance of the net zero buildings, these examples, these cases may give you an idea about what to do more, what we should look at more. To conclude, The 21st century is a period that we should act in a way that respects nature, and also we should generate energy that based on natural entries, natural inputs, and also we should reflect, we should have ecological buildings. And in addition to this net zero building, we also need to pay attention to design, the construction and operation phases so that we can have the zero carbon building to have it more sustainable system and using the materials that are appropriate for zero carbon to reduce the CO2 emissions in the long run. It doesn't have to be commercial buildings only, even individual buildings and also houses can benefit from this. And there is a process that we need to accelerate. That's all from my side. Thank you. Yes. We would like to thank you, dear professor, for this presentation. It is an inspiring presentation. As you rightly mentioned, design, renewable energy and technologies need to be balanced. And in this balance, each building has its own needs, and there is a peculiar characteristics of this building in this respect. I would like to give floor to Ayçam Besen. She has a parallel presentation because she will talk about the rooftop systems. She is from the GTS system. Thanks for inviting me to this conference. We as the GTS, since 2013, we have been working to make contributions to a world with carbon neutral. And we began a power plant, solar power plant in the southeastern part of Turkey. But since the very beginning, our objective was to have efficiency and to build a carbon neutral future and to manufacture materials that are appropriate, that are suitable for this objective. Let me share my screen. Can you see my screen? So our technical team can show your presentation, can share it. Can you see it now? Although my presentation focused on rooftop energy systems, I would like to state my company, the GTS, from 2013 to 2016, we worked on different thickness of glasses, and we are specialized in this issue as a research and development center. And we have a patent on this glass and glass system. It is double phase panel manufacturing. Our panel, solar power panel, it's 1.6 thickness, or it might be 2.3, and we can manufacture these solar power panels in different size, in different types, and we can apply it to the external facades, or we can build it as an external facade, or to replace the windows. It might be applied as an accessoire, like a shading or an annex to the car parking area. So we have these opportunities, and we can use one of them in any part, and we can apply it to buildings, because in the future, what we know this, the cannabis. We think that cannabis will be a main material, a main construction material. And in this respect, we work on this issue. As regards to the roofs, we use these panels which have double faces, and our company is the world leading company because this type of panels are usually applied to constructions or projects that are in the fields, but these panels are important for the operational, and in order to generate the highest level or highest amount of electricity, it is important. But this extra energy, since it comes from the second phase, this type of panel is not used on the roofs. But when we examined the situation in Turkey in 2017, we realized that the industrial roofs, 80% of the industrial roofs was white, which does not reflect a lot. So which does not have high level of reflection. And we decided that we concluded that we can use this design in our system. And this is our factory. And it is the roof of our factory. We applied these panels to our roof in 2014, and it is a research and development center. There are 8 different types, solar panel types, and there are 4 different assembly and montage types. And we use this assembly and montage system that we developed there, and we completed the application of 65 watts electricity generation. And so we generate at least 5% more electricity. So in order to achieve carbon neutral buildings, in order to generate the highest amount of electricity, these double phase panels are inevitable, indispensable. And this slide shows the white floor, and the white floor is compared to gray floor. While the gray reflects up to 20%, the white floor reflects it up to 80%. So in an industrial facility with a white roof, there is a potential of 5% more electricity generation. What we know that with this system, we can apply these products to the roofs. And also our system, it's like the length of an octopus, and we provide maximum resistance, even if there is this wind speed that is 555 kilometer per hour, our panels can resist, and our elements So our materials are solid, and they are so strong that there is no way to harm them. And our panels that are produced, that are made of glass, and they can be used in skyscrapers as well, because they have high resistance level, and in this case there is no way to harm them, irrespective of the wind speed, because they are extra light. It is 150 microns, and there is no way to damage this system. And there is a cover which is made of glass, since it is a symmetrical structure, as you see on the right side. We put all the load there, and they waited there for 3 hours, and nothing happened there, and there is no electroluminescence, and as you see, there is no crack on it. In the middle, we see there's a standard mechanical frame, and it is made of plastic, and we see with the same load, you see electroluminescence situation. Therefore, when we look at this picture, we can conclude that, and also we have tests to check the quality, and our solar power panels are important and strong, because sustainability is essential to our activities. And all buildings that our materials are applied will have no problems up to 30, 40 years, and they can generate electricity for 30 years. And in 30 years, an American institute certified that there will be maximum 14% decrease in our efficiency in 30 years period. And when we set up this type of electricity power plants, and if there is a fire risk, because there is this fire risk, and when we use our panel, which is made of glass, there is a precaution and safety, and we have A+ system, and the fire department in California certified that our systems got A class. It is important, and in a standard panel it is C, but in our case it is AA. And of course, standard solar power panels is not enough to meet the standard that is B1 for the buildings. But for us, in our case, our panels are much better than the standard requirements. Another point is that I would like to state is we have power plants, and please don't think that there's no fire resulting from the panels. The metropolitan municipality in Gaziantep, and stated that do not implement GES in these sandwich panels because of the fires that they faced. We say, no, you can apply it. You can use sandwich panels with no concern, providing that you use the appropriate product. That is the point. The roof integration that we carry out, you can use it on rooftop panels or on bricks, or as the pictures, as the photos show, you can build the roof itself by using our materials. This type of materials, especially, they generate electricity by the lights, sunlights. They can generate high level of electricity, and also it is from 1.6 millimeter to 12 millimeters. Since we use this type of glasses, it is 12,000 Pascal, and we can manufacture solar power panels that become the roof itself. Here, when we compare the solar power plants and also another power plant, that is thermal power plant, and what we know that the technology that we use to generate is very simple. This is the difference, because GES, the solar power plants, do not pollute nature because it is the clean energy. It is much better than any type of power plants that we have discovered so far, that we have invented so far. Let me return to a point. I would like to refer to Cihan Bey because in his presentation he's also stated this issue. These panels that we manufacture with double face, and they can be used in any part of the building because of their characteristics, because of their feature. And we also know that they generate much more energy than the conventional materials. And we can also look at the energy that we consume while we manufacture these panels, because in a conventional panel that we use energy that is much more than our panel, because there is a metal framework and there is a glass of which thickness is 3.2 centimeter, and you need to think about the glass factories consumption. There is a chemical lamination materials, and most of these materials are produced ethyl EVA bases, and these are manufactured as a result of fossil oils or fossil sources. That means there is this energy, and in the middle there are solar cells that generate electricity, and these are polysilicon, which means in order to achieve this high density, one has to use certain amount of energy. And at the back, there is this bat shield. There is a plastic material in this layer, and it is PVC material, PVC-based material, and this PVC-based material causes CO2 pollution. It is one of the most problematic and most pollutant operation. So even though we call it green energy, the manufacturing process is not clean. They pollute environment, and these are industries that can pollute the energy. There is another case that is worse than the solar power. The battery that you store. Everyone uses lithium batteries. And everyone talk about these type of batteries. These batteries are useful for nature, but while you manufacture these batteries, you still pollute the environment. In this respect, GTS is a leading company because all green industry companies need to look at the embedded energy and need to transform this embedded energy into a greener one, into a cleaner one. That is the principle. We as the GTS, what we have done so far. First, we do not use the metal framework. So we do not use it any longer. Yes, we have metal planks, but the distance of these materials is equal to 20% of a framework. So we save nature. We use glass, but comparing to a standard panel, although the conventional solar powers uses 3 millimeter, we use 2 or 2.5 millimeter to save nature. Unfortunately, we use the same poly solar cell, but we created our own factory so as to prevent the transport of these solar cells, because the transport of these solar cells also causes CO2 emissions. And we created our factory to manufacture our solar cells, and we use them in our solar panels. This is our advantages. We have laminations materials. Unfortunately, they are same. They are different in its feature, but their impact on nature is same. We have not made any difference yet, but our real difference is the back shield, because in our shield, we do not use PVC. And we use a thin glass as we do use in the front layer. So it is environment friendly, it is nature friendly, and when the plant is over, this material is appropriate and suitable for recycling. So I talked about the transport's impact on climate. So that is the case in our country. If we use our own materials, unfortunately, this is the case that have been imported. I mean, the imported materials were being used, but if we manufacture our own materials, then we can make contributions to the environmental issues. If we return to local materials, then we can save nature, because transport is harming. And we can save nature. In this slide, you see our factory. You can see the exterior wall of the solar cell. It has been designed in glass only. And these glasses, in fact, are solar power panels. So these solar cells and also solar panels were manufactured in Turkey. And also the roof of this factory is full of solar panels. And these panels have an advantage. And while we use the energy, while we manufacture this solar cell, we need to use energy, but we use the energy from the solar power, that in solar panels. That means we do not consume energy. That means in our factory and also in our solar power panels based in Adıyaman, we use the energy, and our factories are also environment-friendly factories.
Here we look at carbon neutral cell production and the green transformation here focuses on the least harm on the climate. Here we actually highlight the importance of the selection of components, and embedded energy is a very sensitive matter for the industry. And here, the managers in the industry can pay attention to this topic through you consumers, architects, designers, and urban developers, municipality officers, health workers. If you pay close attention to this topic and organize panels, only can we achieve this. Thank you very much for your attention. If you have questions, I'll be happy to take them. Thank you very much, Ms. Besen, for your valuable remarks. We have questions, yes, but first we'll need to listen to Ms. Seda. As you stated, local production is important. The use of local materials is important. That's why R&D and technology investments will be definitive for Turkey moving forward. Now, I would like to move to Ms. Fikriye Seda Atabek, SolarWall Turkey consultant, auditor, and trainer, who will present her opinions about the renewable technologies. Thank you very much. Let me share my screen. I know there are many people who work behind to make this event. I would like to thank you all for letting us introduce ourselves and creating a collaboration platform. The SolarWall product actually supports the views of our professors. If you look for zero energy buildings, we must ensure that we cooperate in the design phase. And SolarWall is a product designed just for that purpose. We always blame the fact that we cannot benefit from solar energy. We say we have plenty of sunlight, but we ask, why don't we benefit from it? Well, of course, electricity system has been in place before the development of the technologies, but I want to focus on heating and cooling these spaces based on solar energy. Sorry to interrupt Ms. Seda, but they say that the presentation is not visible. Maybe our technical team can share. Okay, let's do it that way. The next slide, please. Yes, SolarWall technology can be used anywhere requiring heating. It's a very simple strategy, but it is not well known. SolarWall consists of perforated plate consisting of nanopores. We have micropores of 2005 100 units in square meter, and it is coated with a prismatic paint, which is a special paint. And here it ensures actually air ventilation 100% with fresh air, uses solar energy to heat and also dry the interior spaces. How does it work? Together with the first beams of light in the morning, as the sun rises, the panels start heating, and the heated air is sent back to the back part and actually distributed inside the building through a special fan. And here I can refer to specific numbers so that you can better imagine it. For 1 square meter of solar wall product, you can ensure a fresh air flow of 150 cubic meters per hour. And actually, the heating can be increased from 8 to 15 Celsius degree. And we do it actually with fresh air, and 80% of the sun can be, up to 80% of the sun can be absorbed. Normally, building envelopes or other materials are not that conductive. There's this actually air channel inside the panel, and there's a simple fan. And here solar wall has a wall or process behind it, and we can actually emit the hot weather through that. We can move to the next slide. When we look at the main usage areas, we can refer to any place requiring heating and cooling, but let me highlight first the industrial facilities, including factories, warehouses, drying facilities, and other storage areas. Here we know that food can be dried at a fixed temperature, and it is a marvelous option for that reason. Living spaces like shopping centers and other living spaces can be considered. As for public places, we can think of business centers, schools, hospitals, laboratories. In agriculture and husbandry, we can actually provide heating to greenhouses, farms, as well as chicken houses or other houses, and all farming buildings. Okay, what does a solar wall contribute to my institution? It can be used for industrial and building purposes, and it concerns all consumers needing heating and ventilation there. In today's conjuncture, sustainability-focused institutions or consumers who want to have also reporting as they decrease greenhouse emissions, they can actually benefit from this product, be it a building or industrial facility. They can make use of this technology if they have these concerns. Another fact with the pandemic is that we need clean air. In the past, we would have headache in shopping centers because the fresh air was concentrated to a certain extent, but now as a security measure, they moved to fresh air. That meant increasing the costs twice. Solar wall actually is a unique technology in that sense to actually deal with that cost element. Also, as you know, we have Green Deal, and we closely follow on that, and we need to pay tax for that mechanism, and Turkey will be facing such payments very soon. So the more we decrease greenhouse gases as an exporting institution, the more we will benefit from this technology. Okay, that has been the case for the institutions. What about the buildings? Let's have a building-specific evaluation. We already referred to fresh ventilation, 100% fresh air, and a comfortable and healthy space, preventing actually infectious diseases. And there's this radon gas in lower floors, and we can also prevent that from happening. Also, we can talk about passive cooling. as it provides a shadow effect during the summer months by preventing the heat from going downwards. If you close the damper and not take air inside, you have a cooling effect of 2 to 4 degrees. We do not include it in feasibility studies, though. Think of it like a gift, like an add-on. It decreases carbon emissions because we do not use fossil fuels for the building, and a 5 square meter solar wall panel will actually prevent 40 tons of greenhouse emissions in the environment. And a more exciting feature even is that this panel can be used together with PV panels, providing both electricity and heating, and that means extends the life of these panels with a chilling or cooling effect. We refer to high savings. This is quite an effective, efficient system, as it enables you to have savings in energy consumption. It also contributes to external facade of the building, as it provides protection as a cladding material. We already referred to the fresh air provided by this technology. We said 100% fresh air is sent inside. Another aspect that concerns you is that the solar wall enables you to have points in LEED and BREEAM green building certificates. In LEED, that point increase was as high as 16. As for best building ecological and sustainable design, the certificate in Turkey, it contributes like 85 points, and in the guideline, this product is referred to as sun wall. As for specific design issues, considering that we have architect colleagues here, other than the first investment cost, this product doesn't have a maintenance cost. Other than a simple fan behind, it doesn't have any mechanical components. So you pay whatever you pay at the beginning. And it is designed in line with the climatic conditions. And thanks to the paints on top of it, it is resistant to corrosion and decays. And the predictable lifetime is at least for 40 years. And in New York Fort Drum military base, a solar wall was installed more than 40 years early ago. And we provide it with a 10-year guarantee in Turkey. And if a product completes its lifetime, we can recycle it again. Another property that supports the presentation of our professors. Let's talk about the weight, as Ms. Didem also addressed it. By the way, we can apply it on the new and old buildings, on facades and roofs. And it has a weight of 15 kilograms per square meter, together with Cascas Plus panel, and the panel itself weighs only 6 kilograms per square meter. So it doesn't create a huge static load. It's quite lightweight. In terms of the appearance, the photographs I showed in my presentation generally have black color, but we also have other color options. As you know, black is the color with the most absorbing properties. That's what we recommend most, but there are other color options too. Another very critical point, that's why I wrote it in bold. When installed in a current building, it provides efficiency in many ways, but the best method will be ensuring that you should assume that you will get your heating source from solar wall in the design process. In that case, maybe you will not even need a fossil fuel in terms of the heating load. How do we guarantee the accuracy of our calculations? Red screen, you may be familiar with it. The red screen is a globally accepted software product. We use it, and the database provided by that database, we obtain the meteorological data from red screen. And here you look at the physical structure, facade, and other aspects and carry out feasibilities accordingly. So if you think of this application, we should have a building specific evaluation. Let me refer to its history. It was invented in 1977 by Conserval Engineering in Canada. And in 1985, it was made compatible for industrial application. And the first industrial application was completed in 1986. Then the US Department of Energy likes it very much and considers it to be among the 2% of the energy technologies, best energy technologies, and it is used in with the largest application, Bombardier, with 9,003 square meters, and SolarWall Turkey signs a distributorship agreement. The first application is completed in PIMSA Automotive in 2012, and it is still in good shape, and it is produced in Bursa, Nilüfer, starting with 2017. So we can see that it is a domestic technology now. There are a few types of it. Actually, there's this SolarWall one-stage system, which enables us to provide heating from the facade, lateral facades. And then we have the solar duct, which is a roof type technology. And here, if we do not have enough space on the lateral side, or if we have more space, then we place it with the right angle and provide heating. And here we can actually achieve it together with photovoltaic panels, and even you will be able to see it. PVT electricity hybrid system has an example here. Electricity generating panels have our roof type system. During the operation, these panels get heated, and in 10 years time, they start completing their lifetime. When we place solar walls, though, overheating of the panels is prevented, and you kill two birds with one stone. As for PVT, we collaborate with Smart Energy, Turkey's second largest producer in the industry, and we have such an option for a combined system. SolarWall has won awards and also led certain projects win awards. Prominent ones include PIMSA Automotive, also HKTM is another one. These buildings obtained LEED certificate, gold LEED certificate after the installation of SolarWall. By the way, you see different applications depending on the building structure. And Freetime also had BREEAM certificate after the SolarWall application. A few more examples from factories, one from Tofaş, Tayyip Tusaş. They are all different. Fort Gölcük facilities also have a black panel on top of the roof. And we have many industrial references. Actually, considering the audience, we wanted to install such building examples. I do not mean to elaborate on the details. You can actually see them in the references section of our website, but I want to show various examples. PIMSA already received LEED Gold, and it has an application area of 770 square meters. The Directorate General of Titles and Title Deeds and Cadastre also had an almost 400 square meter SolarWall application, almost half of the building, and you can actually see the calculations about the greenhouse gas gains with our applications. This is CEOZero Green Technology Vocational and Technical Anatolian High School. Here, actually, we can warm many spaces with warm, fresh air. We can proceed. We have many other examples from outside. Cambridge Memorial Hospital is one of them. You see different colors of panels here. This is not black in this picture. Let's proceed. City of Toronto maintenance garage for buses. Of course, during the maintenance, you see the accumulation of excessive exhaust gases. That's why it is a good practice to have fresh air inside. When we look at the mechanical bus garage, similarly, we see that it is actually behind the building in line with the, and it enabled the building to obtain the green building certificate. Erlangen City Hall did not have much space. That's why we use the thin stripe, but still we decrease fossil fuels to a certain extent. These are two different building examples, emphasizing different practices of the product or applications of the product. What about the approximate costs? If we have a current ventilation system in our buildings, and if you want to integrate the product, you can think of approximate costs of 15,000 square meters for 100 square meter. But if we are going to have a new system, then we can say that the cost will be to 25,000 square meters 25,000 euros for 100 square meters, but we need to see the specific buildings for better estimates. And we can say that the return on investment changes from 1 to 4 years. I'm not including the passive cooling demand, of course. Considering the increasing energy costs, this return period gets shorter. That would be all from my side. I try to present it fast so that I do not run out of time. I do not cause delays. Thank you for the opportunity. Thank you very much, Ms. Atabek, for this knowledge. SolarWall is a next generation technology and a domestic technology, very inspiring indeed. Quality, life quality air with lesser carbon dioxide emissions and more savings. Thank you very much for your presentation. We have 6 more minutes. We'd like to now have a question for Ms. Didem. This is a question by our audience. Özgür Khan Alioğlu asks Ms. Didem this question. How do you ensure water insulation in the back part, especially with sandwich panels of roof gas systems? Well, we proceed accordingly. If that roof is covered by roof panels, there are actually hot baths there, twists, and we ensure that the connecting elements are placed on the lateral sides of the elements, and here we apply 4 screws to create the holes. And first we cover the surface with EPEM, and as we apply the screw, we also apply silicone. Sorry, I have my cat here now. So we do not apply the silicone before or after, but actually just there, as we apply torque meter, the silicone should be there. EPDM and silicone lets us actually these holes to be opened in a very healthy way, not actually downwards, providing or ensuring full water insulation on the roof. Our oldest roof has completed 7 years of age, and we did not have any water-related issues throughout these 7 years. Thank you very much, Ms. Didem. Energy transformation here will be very important, and the importance of zero energy building in a carbon neutral future will require the design processes to be renewed as we will move to renewable energy resources and innovative components, and we will need R&D studies and further investments in such technologies. We have 5 more minutes. Would you like to summarize the first steps to be taken accordingly in Turkey? Please, very brief remarks so that we can finish. Can I? Sure. First and foremost, the Ministry of City, Urban Planning, Environment and Urban Planning should make the roofs of the buildings separate units. That is crucial in terms of the renewable energy installed on top of the buildings. Secondly, for the new buildings, we should repeat the green energy criteria, just like in Europe. We should have conditions there. Thirdly, just like in any development, we should pay attention to audits or inspections. Actually, fourthly, we should emphasize the importance of domestic production. Unfortunately, the incentive mechanisms in Turkey do not incentivize local productions adequately, be it in investment documents or incentive mechanisms. We see such subsidies for imported goods. However, by domestic production, we can already make huge contribution to climate. And I would like to underline that we need inspection in every aspect of our operations. Otherwise, the practices are not completed very well. Everything is just stays in the words. Ms. Didem. I agree with Ms. Didem. Inspections are very, very important. There is this standards and regulations aspect of this story, and the state needs to undertake revisions in line with the global practices and also ensure inspection. The second item is financing, and it should be conducted in line with the international institutions, and the prices should be at an affordable level. Another important thing is, I think, education. Architects and engineers alike should be trained in a way to be a part of the teamwork, and they should be able to have on-site internships. They should look at the new practices, and also these procedures should be supported by contests. And we should be able to actually, you can, from the private industry, come to universities and tell how these products can be used. And I think it can accelerate the development. And actually, the chambers of architects also pay attention to that, so that we can ensure a revision in the industry by training these young individuals. Thank you very much. Ms. Seda, thank you very much. I agree with other participants in terms of awareness and design. I would like to add that when we plan our investments and conduct feasibility studies, we have a cost-focused approach. However, we should maybe digitize the risks of climate change and factor them in accordingly. When we do not make an investment due to cost reasons, we should, I think, know what awaits us. So we need concrete tools there to measure it. Thank you very much. I would like to thank all our participants for their valuable remarks and insights. This marks the end of this session. Thank you also to our audience. Bye-bye. Take care. Bye.